All right, in this one, we're going to use what we looked at in the last video, which was the idea of significant figures, but we're going to actually do a little bit of math with it this time. So there's two rules, multiplication division rule, addition subtraction. Let's start with multiplication division. We look at a rule that says the number with the fewest significant figures determines the number of significant figures in the answer.
Whoa.
Wow, that's a lot. Sorry, I tried to read as fast as possible. So, for instance, we go 1, 2, 3, there's 4 significant figures here. There's 1, 2, 3 significant figures here. Which means...
So the fewest, which is 3, is going to determine the sig figs in the answer, which means our answer can only have 3 sig figs.
Right. Think of it this way. You've probably heard this before. You're only as strong as your weakest link. Your weakest link is lowest sig figs. That's your weak link. However few significant figures you have in one of your measurements, that's where your answer has to go. It seems completely crazy. We take this completely reasonable 324.103 grams,
right,
and we reduce it down to 324 grams. Sorry, that's just the way it works. You have to do it that way. Again, this is so we can keep track of where our estimates are. So he's known, he's our new estimate.
All right.
Right?
Okay.
Normal rounding rules apply. 5 and above rounds up. 4 and below rounds down. None of that even odd garbage. I don't even remember how to do that.
Well, they might hit that in physics, but
yeah, it's physics problem.
Yeah.
Okay, so next slide. We're gonna do the same thing we did in the last one.
Okay. Yeah. What we want you to do
hit
is
pause, give it a go, and then we'll talk through each of them real quick.
Yep.
Okay. So what I want to do first is we need to know how many significant figures there are in each of these. There's 3 sig figs here. Trailing 0 with a decimal, there's 2 here. I'm just going to go ahead and write all of them on here. 4 sig figs, 3 sig figs, 1, 4, 2. Remember, he doesn't count because there's no decimal. 2 sig figs.
That 0 counts because there's the decimal.
5, 3, 1, 2, 3, 4 because of the decimal. 3 significant figures there.
Okay, so when you're multiplying and dividing, go ahead and just get your answer. So this is what your calculator should say for the first one. Now, we've got 3 significant figures versus 2. Our answer can only have as many sig figs as the least number of sig figs in your calculation, which is 2.
So 1, 2.
So, and then we've got the 6.
Clear around that way, which means your final answer would be 23 meters squared.
Right. The first 2 is your first sig fig. The second 2 is your second sig fig. And the 6 tells you to round up. So we've got 23 meters squared. Okay. All right. Second one. And this is where Mr. Friedman and I, if we get an answer that has all these decimals on it, we're going to put a great big X through it. There's no way you want to write down 4.219409283. Okay, you've got 4 sig figs and 3 sig figs. We stop at 3. What does that 9 tell us to do?
Tells us to round up. You get 4.22 grams per cubic centimeter.
Right? Doesn't that drive you nuts when they write all those digits?
It drives me nuts.
Yeah, we don't need all those numbers.
Congratulations, your calculator told you what it was. It can't tell you what to do with the answer, though. That's the difference between them. All right, how about for the last 4, we just kind of put up the answers so they can check them.
Okay, so...
You start talking about the centimeters squared, and I'll click through the rest of it.
Centimeter squared?
Centimeters squared.
What about it? Centimeters times centimeters?
I meant how that one worked.
Okay, so you've got 0.04742, 1 sig fig. Now the first 0 is not significant. The second 0 is not significant. So your first significant digit is that 4. 7 tells you to round up.
Could you write this in scientific notation?
Yeah.
Sure.
Oh, yeah. 5 times 10 to the negative second centimeters squared.
Okay, take a second, check your work on the other 3.
Yep.
See if you got what we got.
And then we'll tackle questions.
We can talk about them in class.
Okay.
Okay.
Yeah. Let's take a look at adding and subtracting. Okay, this is the one that I think is more difficult. You'd think we'd talk about addition and subtraction first, but no, it's really
this one's more difficult.
Interesting. When you add and subtract, the number with the lowest decimal value, you might want to underline decimal value, determines the place of the last sig fig in the answer. So now we're looking at place value, not number of sig figs.
Yeah, this one's all about where they are, not how many there are.
Right. So we've got 2 measurements here, 3.75 milliliters and 4.1 milliliters. You put that in your calculator, you get 7.85. Seems like a reasonable answer. Okay, so now we have some different rules for adding and subtracting with sig figs. And notice it says the number with the lowest decimal value. So we're not actually counting number of significant figures. We're going to look at decimal value. We usually cover addition, subtraction second because
It's harder.
It is.
Sort
We're
of.
so used to counting sig figs,
Yep.
and now we're not. We're looking at decimal value.
Yeah, it's all about where the significant figures are.
So you've got 3.75 milliliters, and you're adding 4.1 milliliters. So number one thing, when you're adding and subtracting, the units have to be the same.
Correct.
But the precision of these two measurements are different. The 3.75 goes to the hundredth, and the 4.1 goes to the tenth. So which measurement's the least precise?
The 4.1, same as it was before. You're
Right.
only as good as your least precise measurement. The reason I put boxes there is it's kind of hard to see the brown on the brown. What we did was we highlighted the estimate. It's all about
Right.
where your estimate is.
So if our least precise measurement is 4.1, it goes to the tenth. Our final measurement cannot be any more precise than our least precise measurement, which means we
use
can
this-
only go to the tenth. There we go.
Didn't see that one. They're my fault.
Yeah.
Okay.
So we're actually going to record as our final answer 7.9.
Yep. And the reason I drew that line there was I have the box here on the 1. Here's this estimate. Here's this estimate. If you find your leftmost estimate, your farthest to the left, draw a line up along it, all the way down. You notice I rounded from one side of the line to the other. It's just a visual way that I found that kind of helps some students.
Yeah, and usually when I talk to my students about this, I say you're looking at the least precise. So let's take a look at the second example. You've got 224 grams.
All right, here's
Your
our
estimate is a 4. Now, the other one is 130. That 0 is
Does not
trailing and it doesn't have a decimal. So your last estimated digit there is a 3. So we're really dealing with the 1s and the 10s. The 130 grams is your least precise measurement, which means you cannot go past the 10s
Correct.
spot. So we're going to take 354 and we're going to round it to the nearest 10.
And we're going to round it to 35.
No, because that's not the 10s.
Oh.
You
What did I
just changed 354 to 35.
Ow, I forgot about the 0.
We're
My-
rounding. You know what? Your students do that all the time.
That's why I did it.
Yeah,
I'm
they
not-
changed 354 to 35.
Yeah,
Yeah,
remember
no.
we talked about money. You want $4 or you want 400? The zeros are placeholders.
And we're rounding. You
Yeah.
know how to round 354 to the 10 spot. It becomes 350.
It seems crazy. Why would we take perfectly valid 354? How would you magically lose 4 grams? That's not what we're saying. Because of the estimation, you can only be as precise as 350 grams. That's the best you can do based
Right.
on your instrumentation.
All right.
Okay.
So try these examples
Okay,
and
same as last one.
pause for a second and we'll take a look at the answers.
I'm not gonna do any writing.
Okay, so let's take a look at the first one, 3.24 and 7.0. Your calculator will say 10.24. You always should say, do I need to write this whole number? Now, you're adding and subtracting. You've got 3.24, which goes to the 100th. You've got 7.0, which goes to the 10th. So your answer cannot go further than the 10th spot. So we record 10.2.
Okay.
Now let's go ahead and flash through the rest of them. You can check your answers. And in class tomorrow, we can kind of go through and, talk about how we came up with this. Specifically, look at that last one.
Yes.
You want to, because your calculator is going to tell you 0.16 milliliters.
But you need 0.160, trailing 0, but decimal, which means he counts.
Right, but why? Take a look at the 2.30. You go to the 1,000th place, right?
Yep. If you write it out like that, it's a little bit easier to see.
And the 1.870 goes to the 1,000th place. Your answer
So it
has
must go to the 1,000th
to go to the
place.
1,000th. All right. So that's it. We'll do lots of
One more
practice in
thing.
class.
One
Oh,
more
do we have
thing.
one more
You're
thing?
just jumping ahead here.
I am.
One thing. It's a special
Oh.
case that we didn't talk about
Oh.
yet. This doesn't really fit anywhere. It's called exact numbers,
Oh,
and they do not
yeah.
limit the number of significant figures in the answer. For instance, if I say there's 12 students in the room, is there any question on how many people are in the room?
No.
There's no estimate. If there's no estimate, that means your significant figures never end, which means there's an 8 that got tired. Also known as infinity.
You got it.
Okay, also known as infinity. Okay, exact conversions. 1 meter is equal to 100 centimeters. There's no significant figures in there. Okay, and then conversions, we'll kind of get to those later.
Yeah, basically what we're saying is when you're adding, subtracting, multiplying, dividing with counting numbers or exact conversions, you don't...
You just kind of ignore them for significant figures.
Right, because they can have an infinite number.
Right.
If you have 12 students, you're never going to have 12.5. You're hopefully. So basically, your significant digits keep going on and on and on and on.
All right, I think that's enough for significant figures.
Yep.